Geometry Teacher Talk over Concept 7. Before watching this video, please make sure that you've gone ahead and tried each of these problems on their own. If you like to do them one at a time, it's totally fine, but make sure to pause the video now and try these on your own first before looking for the solutions. In Concept 7, we talked about algebraic properties and how to do an algebraic proof. The very first thing we want to make sure that we can be able to do here is know our algebraic properties. For the first one here, it says if x minus 5 is equal to 12, then 12 equals x minus 5. Notice in this case, all we did was we swapped the left hand and right hand side of the equations, and so since there's two separate parts and we're just swapping them, they're equal to each other. This is going to be the symmetric property. On the second one here, we have, says if 2x equals 8, then x equals 4. Well, if we look at the left equation and then to the right, we have to think, how did we get from the first to the second part? Well, if we note, what we did here is we divided both sides by 2. And so since we divided both sides, this is going to be the algebraic property, in this case, division. So this is going to be our division property here. Our next problem here says, write an example of the addition property as a conditional. So I'm going to go ahead and do this, but your example might be a little bit different. As long as it uses the addition property correctly, it should be okay. Remember, conditional is a form of an if-then statement, with the hypothesis coming first, followed by the conclusion. So I went ahead and started with the hypothesis. If x minus 2 is equal to 1, well, the addition property says that we need to add something to both sides of the equation. So in this case, I went ahead and added 2 to both sides and got x equal to 3. So and as long as you added something to both sides of your equation and your math is correct, that would be perfectly fine. The next example here says, finish the conditional using the division property. So since the hypothesis here says if 48x plus 16 equals 12, then 12x plus 4 equals blank. Well, if we think about how we got from the first equation to the second, we're using the division property. To get from 48x to 12x, that would be the same thing as dividing by 4. Same thing, get from 16 to 4, well, you also have to divide by 4. So since that's what we did on the left side of the equation, then we also need to do the exact same thing with the right. And so we would get 12 divided by 4, which in this case would be 3. Now that you've practiced your algebraic properties, now let's put those together to use a proof. Remember, the first part of a proof is that we always want to go ahead and write statements and reasons on our columns, so make sure we have that. And our first statement is always the given, which in this case is our equation. And our first reason is just going to be given. From here, then we can go ahead and start solving our equation. Well, since we have those parentheses there, we need to go and get rid of those. And so we're going to take that negative 9 times 3 and get negative 27. And negative 9 times a negative x giving us a positive 9x. And remember, doing that multiplication there is the distributive property. Since we're still only doing on that left-hand side, so this is going to be distribution. From here, we might note that on the left-hand side, we have that 2 and a negative 27, or just think of that as 2 minus 27. And so if we go ahead and combine those like terms, we're going to get a negative 25. But since this is going to be combining like terms, it's only on one side of the equation, so this is going to be substitution. From here, since we're trying to get the x by itself, that means we need to go ahead and move that negative 25 over to the other side. Well, since it's a negative, that means we need to go ahead and add 25 to both sides, which would give us 9x equal to a 30. So we have, since we add on both sides, it's going to be our addition property. Finally, to get x by itself, we need to go ahead and divide here. And so that's going to be 30 divided by 9, which would be our division property. Now you might note here, though, that 30 over 9 can be reduced. So I'm going to go ahead and write that in this reduced fraction form by taking a 3 out, which would make it 10 over 3. And I'm going to write my reason as simplify. In this case, this could also be substitution since we're reducing it. Either of those options would be totally fine. In our next proof here, we're going to start out the exact same way with our statements and reasons and writing our equation as our first statement and our first reason as given. In this case, we have 8 plus 9 plus 2 equals 6x minus 4. Well, if we look at that left-hand side here, we might note that we can go ahead and combine those all together. And so if we take 8 plus 9 plus 2, we get 19. Since again, it's only on one side of the equation, this is going to be substitution, or combining like terms. From here, then, we're trying to get the x by itself, so we need to get rid of that minus 4 next. In this case, then, since it's a negative, we're going to have to add 4 to both sides, which would make that 19 plus 4 equal to 23. And so we get 23 equal to 6x using the addition property. The last thing here to get x by itself then means that we need to go ahead and divide by 6 to undo that multiplication. So this gives us the fraction of 23 over 6 equal to x. But remember, our final line of our proof should always have the variable coming first. And so since we know 23 over 6 is equal to x, then that must mean that x is also equal to 23 over 6. We're just going to be flipping those two sides of the equation. And that's going to be done by using the symmetric property. Pause the video here and go back and review any of the examples. If you have questions, please see a teacher.